So formaldehyde, I don't exactly know what reaction takes place, but it is poisonous to living tissue. Like if you ingest formaldehyde, it's going to be poisonous. You need to like clean that up quickly. But I think there is like it acts on cells and tissues, and it like so living tissue is soft and it's constantly changing, right? If you don't provide it that like constant nutrition, if you don't keep eating food and all, uh like when a tissue dies, uh bacteria, fungi, all these things act on it and it gets decomposed, right? So formaldehyde, I think, one, it prevents like all the microbes from acting on living tissue, and two, I don't know exactly what it does, but it preserves the structure of the tissue to remain as it is. That's why it's used in preserving things. Okay, so yeah, the last property can talk. So the lower aldehydes have sharp, pungent odors. It's unbearable. It's very bad smelling. But the ketones have, and higher aldehydes have bearable smells, like they're more fragrant. You can't use them as perfumes, but at least you can tolerate the smell.
Oh, that's why we like whenever we test for aldehydes or ketones in the lab, we like sometimes they ask the observation is usually related to smell, like pungent smell or pleasant smell or something.
Possible, but again, the pungent smell you only find in the lower aldehyde. Mostly with formaldehyde is very, very strong. Maybe acetaldehyde and propanol. Uh, but yeah, like if you know that
Every experiment smells very bad. They just say pleasant smell. It smells very bad.
esters are like trademark, their selling point itself is their sweet smelling. So they should be an exception, right?
For alcohols, there was pleasant smell as an observation, and not for aldehydes.
Yeah, and Kaveri and I got a beautiful smell from that.
I wouldn't say alcohols would be okay. Pleasant is a subjective term. Compared to formaldehyde, for sure, it's a lot. It's very pleasant. That much I would say.
For carboxylic, also pleasant is one of the observations.
Really? Okay, that's also subjective because you guys have smelled vinegar. You know how it smells, right? So
We got like a terrible smell, and then it was supposed to be a pleasant smell, and then we went to our teacher and we were like, "Ma'am, can you please smell it?" And everyone was putting it in her nose, and she's like, "I'm not smelling anymore of this."
yeah, terrible, pleasant. Again, these are all compared to what?
It's subjective.
Yeah.
So, but then that's very questionable that our teacher finds it pleasant. Sorry.
Oh no. Okay, when you're like on a scale, if you're comparing formaldehyde with all these other things, like sure, vinegar, like carboxylic acid, I would put it at a pleasant end. At least it's something that you consume, that you can eat, drink. Alcohol also okay. Acetone that way is a lot more pleasant compared to all these things. Yeah. So ester, have you guys worked with ester in the lab? No? Okay. So that's supposed to be sweet smelling. It's like its use. The reason why esters are produced in factories is for the purposes of perfumes and all these things. So supposed to be sweet smelling. Okay. Cool. So we'll start with chemical properties. Okay, we'll not do we'll do like two reactions and then we'll stop there. Okay.
Oh,
So
before that, since you were talking about smells, I have like a perfume and I was reading the contents and there's ethanol and butane, isobutane, propane, methyl, propylene glycol, and yeah, very surprised to know there's butane and isobutane.
Yeah, that even like those are not smell contributors. I think they must be, I don't know, solvents or something. But alkanes are you don't smell alkanes; they are odorless. Humans can't detect those.
Which perfume is it?
Some random deal.
And isopropyl alcohol, oh, you said it's a deo, no? Like deos and perfumes are different. So deos have that added thing of making you not sweat, right? So they would have chemicals for smell and they would have antiperspirants, like things that kill bacteria. Like some of them work by killing the bacteria on your skin. That is the one producing the bad smell. And some of them work by I don't know, plugging like something
Don't
to
they like
sweat
clog the
glands.
pores or something?
Yeah, that's what it's some like they work with the sweat glands itself, either like getting into the pores and stuff like that. So that we'll have to see. Okay, so back to chemical properties. So both aldehydes and ketones. So this is the most characteristic reaction specific to aldehydes and ketones. So they undergo nucleophilic addition. Okay, so remember, like for alkenes, we said uh, electrophilic addition was like a characteristic reaction. You had a lot of addition reactions specific to them. For haloalkanes, haloarenes, substitution was their characteristic reaction. So replacement of that halogen group with other groups. Substitution was a thing of theirs. So that way for aldehydes and ketones, nucleophilic addition is the characteristic reaction. The reason, like the mechanism for all nucleophilic addition is the same. So this is standard. This will be the first step in all the reactions that we study in this particular section. Nucleophilic addition. So the attacking one is a nucleophile. So it has negative charge. It acts, so both aldehydes and ketones, the same center, C double bond O is the reactive center. Oxygen has delta negative, carbon has delta positive. Opposite charges attract, so the nucleophile always attacks the carbon. So these electrons migrate over here. So this is the rate determining step. This is the slow step, attack of the nucleophile. So the sp2 becomes into sp3. So these two are anyway always there. Then nucleophile, when it attacks carbon, gets added over here. Oxygen के साथ जो double bond था, that becomes a single bond and there's a negative charge concentrated here. Then most of the times, depending on like what reagent you're using, either you're going to have a positively charged end. So most of the times it's H plus. If you're using acidic medium, it's going to be H plus, or if it's like addition of water or HCl or something, it's going to be H plus. This is a faster step. So you end up getting nucleophile added to carbon and this turns into OH. So this is the addition product. So this intermediate, because this changed into sp3 hybridization, this is a tetrahedral alkoxide intermediate. Simple. So you have alkyl group, whether it's an aldehyde or a ketone, you have a hydrocarbon and you have an oxide ion like attached to it, O minus hai idhar. So that's why it's an alkoxide. sp2 trigonal planar turned into tetrahedral. So it's a tetrahedral alkoxide intermediate. So nucleophile is attacking carbon. Addition reaction. So the addition is across C double bond O. Okay. So all the reactions that we come across, this is the basic thing that happens. So if it is H2SO4, H plus gets added over here, and the other part, like sulfate group, is added to the carbon. If it's HCN, nitrile group added here, H plus gets added here. So all of them follow the same thing. The specifics of it changes depending on the reagent. So like we're just gonna be looking at, okay, what is the context? Is this industrially used somewhere in order to produce, I don't know, sulfonic acids or whatever that way? Okay. So another important point with nucleophilic addition. So both aldehydes and ketones will undergo the same mechanism, but what do you think about the reactivity? So which one would be more reactive, aldehydes or ketones?
Aldehydes, because in ketones there is like another R group which will cause steric hindrance, or I don't know.
Yeah. So if it's like a space issue, that is steric hindrance. Yes, that is absolutely right. That extra R group is going to cause steric hindrance. Because see, nucleophile has to attack carbon, right? So if you have hydrogen versus something bulky, carbon with lots of hydrogens, bigger atoms going to cause like take up more space. It's going to be difficult for the nucleophile to attack. So steric hindrance is one. Another reason is has to do with, okay, so nucleophile ke liye, it's important for this carbon to have this positive charge. Okay, so I'm gonna write it here. So if you see aldehyde, you have C double bond O and hydrogen here, R over here. Ketone mein you have C double bond O, alkyl groups on both sides. In which case will you have a stronger positive charge on carbon? Aldehyde or ketone?
Aldehyde,
Yes. And why?
because the R group, because the in ketones there's another R group which is electron donating, whereas in aldehydes there is no R group.
Correct. So alkyl groups are always electron donating, but ketones have two of these alkyl groups. So that's going to reduce, because of the electron donating nature, plus I effect, say, the effect of this positive charge is going to be slightly reduced. So which means nucleophile will be more attracted to the carbon of the aldehyde rather than the carbon of the ketone. So steric hindrance is one reason. The other thing is plus I effect. The plus
Yes.
effect of R. Yeah.
Which one can we help?
Yeah, it's too heavy.
ठीक है. Okay, so this is the introduction, guys. This is what we'll be studying. Cool. We'll start reactions tomorrow then. So nucleophilic addition may we have 3 reactions, 4 reactions. Alcohols be here. Oh, ammonia is also there. Fine. This is the heaviest one. Others, you'll just have reduction. Reduction, you already know aldehydes, ketones, when you reduce what you're going to get. So just some extra reagents like reducing agents you'll have to learn. Oxidation is also pretty simple. You know, what do you get on oxidizing aldehydes and ketones?
Carboxylic acid.
That's it. That's also pretty simple. And then, yeah, the remaining few oxidation reactions, like the tests are important. Tolerance test, Felling's test. Have you guys done these tests in the lab? If you've done that, that also becomes pretty easy. No, okay.
No, we have.
You
We
guys,
have done.
yeah, you guys have. Smera has it. So what labs are going on, Smira? Like, are they going along with whatever's going on in your class right now?
We do salt analysis every week for the past 4-5 weeks. I am tired. We're doing the same kind of experiments, heat the dry salt, then heat the aqueous salt and everything. It gets very boring.
Yeah. Yeah, maybe like just that because you've started organic abhi, next term you'll probably have all the organic experiments. They're going along with the class. Cool. So all these tests are there. And alpha hydrogen. Okay. Aldol condensation cross aldol. हो जाएगा. So 4 reactions are heavy, the others are pretty small. So we'll do this tomorrow. ठीक है. Okay. Okay. Keep revising, guys. Again, a lot of reactions, a lot of information here. Just have to keep revising this particular chapter.
Thank you, ma'am. Bye-bye.
Okay. Cool. Bye.
Thank you, ma'am. Bye, ma'am.
Thank you.
Thank you, ma'am.